Refrigerated purging differs from basic manual purging by utilizing refrigeration to minimize refrigerant loss during the process. Unlike automatic purgers, manual refrigerated purgers still require an operator to control the purging process. A refrigerated purger is a device that is designed to receive foul gas from areas where non-condensable gases collect. In the purger, the foul gas passes through a cooling chamber or coil where it is chilled. The chilling process causes the refrigerant to condense and separate from the non-condensable gases. The condensed liquid refrigerant is returned to the system, while the non-condensable gases are manually vented into water. Refrigerated purging is preferable to non-refrigerated manual purging because it minimizes refrigerant loss. The removal of non-condensable gases, however, requires an operator to open a valve, so all line break safety protocols must be adhered to.
So one definition of distillation is the separation of components by exploiting differences in boiling point. And in that way, purging non-condensable gases using refrigeration is actually a form of distillation because we're exploiting the fact that the refrigerant will condense and the non-condensable gases won't in order to separate them into their individual components. So we don't call a purger a distiller, but it kind of is if you think of it that way. All right, now let's talk about using a manual refrigerated purger, which I've depicted here on the whiteboard. Keep in mind, a key word here is that it's manual still. So this is gonna be done by an operator manually, so it only can be done by a trained and qualified person. However, by using a refrigerated purger, it offers a better means, a more precise means to separate refrigerant from the non-condensable gases in order to purge safely. So here's how it works. First, imagine on this depiction that all the valves displayed here are in the closed position. And we're gonna kind of walk through how an operator would go about using a manual purger. Step one will be to open this isolation valve, which then exposes the coil inside the purger to low pressure and low temperature, all right? That begins kind of the cooling process, but not fully yet. Step two, once that's open to suction, we are gonna crack open this expansion valve, which is connected to high pressure liquids. We got high pressure liquid feeding through an expansion valve, which will cause it to become a low pressure, low temperature liquid, all right? And begin feeding through this coil. This valve, of course, is closed still at this point. So we're just basically starting to cool down this coil or cool down the purger, all right? So step three, we're gonna open our foul gas isolation valve, and that's this valve here. Now, as we open that valve, that is connected to the condenser drain, really similar to like this connection point up here. So it's gonna be pulling like from the condenser drain line, some liquid ammonia as well as non-condensable gases like air, all mixed together. We call that foul gas. And that begins to fill up the purger. And we're gonna monitor the filling using this sight glass here. All right, and so as this fills, the refrigerant that's entering is getting cooled by that cold ammonia inside this coil and causing, if there is any vapor, for it to condense. Of course, the non-condensable gases will not condense, so they'll collect at the top portion here. All right, so we're separating the two from each other. All right, once we can see the level in this sight glass, now we're gonna close our expansion valve to allow no more liquid in because we're satisfied, like we filled up our purger, like we're ready to take the next step in this process. Now, we can harvest some of that liquid that's condensed by opening our condensate return valve. Okay, that's a valve, and just crack it open and it'll begin to feed that into our coil. But we don't want to overdo it there because if we feed too much liquid through our coil, it will be supplied back to the compressors, which could slug them, which would be a bad deal. As we do this, our liquid level is going to drop, which is going to be an indication that we're collecting our non-condensable gases at the top. And once we're satisfied that we've collected all the non-condensable gases, we will use this bleed valve at the top of the purger in a very similar manner as I already described in a previous video, which is we're going to open it into a source of water. We should see a lot of bubbles here because this should be primarily non-condensable gases now, so bubble up through the water, but any refrigerant, any ammonia will absorb with the water and form an aqueous solution. Once all the bubbles stop, our purging is done and we can return to normal operation with our system.